So we are going to be focusing on division with and without remainders. Division without remainders is a lot more friendly than division with remainders because it goes in evenly. We love division without remainders. As we continue getting older and doing more advanced math, those remainders turn into other things. So it no longer would be a remainder, it would then be like maybe a decimal or a fraction of another number. Okay, that's really what a remainder is. All we're doing today is focusing on regular division involving remainders and then regular division that is all, it all works out perfectly and so nice without anything left over. Okay, so let's just kind of refresh our brains. For long division, you divide, then you multiply, subtract, compare, bring down. Okay, I used to call it dad, mom, sister, brother. Okay, or does McDonald's sell cheeseburgers? Have y'all ever heard that acronym? Yeah, okay. So it's a quick way to kind of remember the steps for long division, which is everybody in here's favorite whenever I asked you how you felt about long division. So we are going to practice just a really short problem. It's 16 divided by 5. I'm going to check our work by multiplying. So go ahead and take out your dry erase board. It is just a 2-digit divided by a 1-digit. We're starting out small. I want to see what your long division looks like. So work this out on your whiteboard. If you're at home, pause. You can check your work when you're ready. All right. Y'all are showing me some awesome stuff. This is the most common one.
15 and a remainder of 1, I'm guessing.
This is the most common way that I saw around the room. Most of you set it up just like this. Okay? You ask yourself, okay, first, divide 5 into 16. I know 5 goes into 16 3 times. Now this is where the multiplication part comes in. 5 times 3 is 15. Okay, now I'm going to subtract. I have 1 left over. Okay, do I have anything to bring down? No, so this is just remainder 1. So 3 remainder 1 should have been your answer. I saw another interesting way to set up this division problem. I saw one person with this. Remember, there are 3 ways to set up a division problem. Okay. I also saw this. 3 different ways to represent a division problem. Okay. Here's another problem. This is a word problem. So we're going to apply this together. We're going to work through it together.
Are they Pokemon trading cards?
Oh, don't think so, but we can pretend.
Okay.
Okay. 50 trading cards are to be placed in protective pages. Each page can display 8 cards. How many pages can be filled? Okay. What's the least number of pages that is needed to protect all of the cards? So we've got a couple questions to think about. First, how many pages can be filled? Whoa, my accent just really came out there for a second. Okay, how many pages can be filled? If I have 50 cards and each page can display 8 cards, how can I figure that out? What did you do? So we did 50 divided by 8. Would that tell me how many pages can be filled? If I did 50 divided by 8 cards. I take my total number of cards divided by 8 because 8 cards can fit on 1 page. How many times can 8 divide into 50?
5,
6. 8 times 6 is 48. Okay? But I would have, after I subtract, I would have 6 remainder 2. I've got 2 cards left over. So first, my first question is, how many pages can be filled? Can 7 pages be filled, or can 6 pages be filled? Only 6 can be completely filled. So we would put 6 can be filled. And it says, what is the least number of pages that is needed to protect all of the cards? Yes, what would you answer?
6 and a 4.
But can I do fourth. Okay, so I can't just take a fourth of a page. I'm not going to put a fourth of a page in a binder. I'd have to have a whole page, right? So then how many pages would I have to have? 7. You would have to have 7 pages. Okay, think about like if you go to the store and you needed like a can and a half of something. You can't just say, I only want to buy half this can. They'd look at you like you're crazy, right? They'd be like, we can't do that. We can't chop that can in half. You'd have to buy the whole thing. Same concept here. You would need to do 7 whole pages. So what is the least number of pages that is needed? 7 pages would be needed. Now, are you going to fill up that entire 7th page? No, You'd only fill up, like Sammy said, a fourth of it. Does everybody understand how he got that part?
Yes, ma'am.
Because how many cards can fit on a page? 8. And if I only have 2 left over, 2/8 of a page. Picture that for just a second in your mind. Here's my page. I have 8 cards that can fit, and 2 of them are filled in. This is like a fourth of the page. See how that broke up there? That's why he said that. Okay, next. At an amusement park. Oh, this question should be fun. You should love division because it's about an amusement park, right? It makes it so much better. Okay. Oh, waiting in line's the worst. Okay, so at an amusement park, 16 people are waiting in line, but that's not too bad. 16 people for a water ride, and each boat holds 6 people. So we want to know first, what is the least number of boats needed for everyone to ride? Okay, how can we solve this? There's 16 people waiting. Each boat holds 6. What would I need to do?
16 divided by 6.
Okay, hold on. If I didn't just call on you, please make sure that you're quiet and listening. So she told me we are going to do 16 divided by 6. First step, divide 6 into 16. How many times can 6 go into 16? Only 2 times. What is the multiply part? 6 times 2 is? 12. Now I'm at the subtraction part. I subtract. I have 4 left over. 4 what left over?
4 people.
4 people. Very good. 4 people left over. So what's the least number of boats needed for everyone to ride? Can I have remainder 4 boat?
No.
A lot of you are showing me the exact answer to remainder 4, but the question says what's the least number of boats? Why?
It's the answer is 3 because you need to add 1 more boat to fit everybody.
Yes, because I can't just say, oh, just give me part of that boat right there. I'm just going to like cut it in half because it would sink. It wouldn't have enough sides, right, to keep it afloat. You can't like take a part of a boat. So you would have to go up and have 3 boats.
3 because.
And how do we know?
Because that's how math works.
Because that's how math works.
Because I said.
We just kind of answered it a second ago. You can't have part of a boat. Okay, you have to add a whole nother boat.
I got it. Because the shuttle and they don't use all their boats.
Hey,
Maybe.
don't
Maybe.
get so did
All right. Same problem. Same scenario, different question. If 2 boats arrive at the loading dock, how many people will have to wait for a ride?
I don't know. Well, how many people?
So we just worked this out, right?
How many people the boat can hold?
16 divided by, well, we know that each boat holds 6 people. Same problem. It's the same problem. So if I had 2 boats arrive at the loading dock, some of you are showing me your answer. Thank you. Y'all are correct.
Yeah.
Then how many people would have to wait for a ride, everybody?
3.
Whoa. 4. My remainder of 4 people is my answer to this part of my question. 4 people would have to then wait. Okay, same scenario. Same scenario. If 3 boats arrive at the loading dock, how many boats can be completely filled?
Really, Bryce?
Can you have 3/4 of a boat?
No.
2. 3 boats.
Only, very good, 2. Again, same problem.
Man, people are on this dock for hours.
2 whole boats will be filled. You cannot have 2 and then part of another boat. Okay, let's look at this for a second. Sometimes we can use divisibility rules. Raise your hand if you know what divisibility rules are.
Does that have something to do with invisible?
Okay, we're going to talk about it. Divisibility rules help you know what a number can go into, what a number can divide into. Okay? So if I have this part, this little section of a multiplication table, it says, are all the numbers in the 2's row even or odd? I'm looking at rows, so I'm looking right here in my 2's row. Are all of these numbers even or odd? Yeah, even. Good. Some of you are showing me on your whiteboards. Some of you saying it. Okay, they're all even. So, is it safe to say that if I give you an even number that may be really big, that I know I can divide that by 2? Is it safe to assume? Yes. Okay, look at my very last digit right here. It is an even number. I can count by 2's. If I really wanted to count by 2's to get to this number, it would take me a long time. But I know that I can divide even numbers by 2. That's a divisibility rule. If it can be divided by 2, then, or if you can count by 2's, if it's even, then it can be divided by 2. Okay, I'm going to erase this part so I have a little bit of room. For 5's, what do you notice about 5's? What do all of the numbers in the 5's row end with? Good. Some of you are showing me. Yes. Tell me.
5 or 0.
5 or 0. Okay. So would it be safe to assume that any number that ends in a 5 or a 0 could be divided by 5?
Yes.
If I gave you another big number, it ends in a 5, could I divide that by 5? Yes. Divisibility. It is another rule of divisibility. If a number ends in a 5 or a 0, it can definitely be divided by 5. What do you notice about the tens row?
0.
They all end in,
Oh, I just have a question.
hold on, they all end in 0. Question.
Are the people waiting for the boat still there?
I hope not. Okay, so what do all of the numbers in the tens row end with? They all end with a 0. So it is safe to say that if I have this number here and it ends with a 0, I can divide that by 10. Yes. Okay, there are more rules for divisibility that we're not going to go over right now today. We're going to focus on these. These are the easy ones to learn first. Okay, so without dividing, no dividing, put your lids on your markers. Without dividing, decide which 2 division problems below will have a remainder. Without dividing, thinking about those divisibility rules that we just talked about. Okay, which 2 do you think?
10 and 45 and 2 and 16.
Okay,
That's a possible.
so we have 45 divided by 10. Okay, if I can divide something by 10, what did we say the number has to end in?
0.
A 0. Okay, is this last digit a 0?
Nope.
No, so we know for sure that it is not going to be divisible by 10. What did we say about numbers that are divided by 2? What kind of numbers do they have to be? Even. This is an odd number, so it cannot be divided by 2 evenly. I would have a remainder. Can I divide these numbers? Absolutely. I'll just have a remainder. Okay? Okay. There's our quick little review on division. We aren't working with super long division today. Not super long. We'll get there later. Today is just kind of simple. reviewing the process of division, building, getting ready for that long division when it comes. Your written practice today is on pages 157 and 158. Numbers 2, 3, and 4 require you to have an equation written before you solve the problem. Please read carefully, and if it tells you that you need to write a specific type of a equation, you need to write a specific type. So if it tells you multiplication, make sure it's multiplication. Okay? All right, any questions before we start?